All right, so we're going to go over compound inequalities today. I don't have that many of them, so um, this video is not going to be long. I need you all to take out a sheet of paper because you're not going to have enough room on your notes and write down this information. Take out a sheet of paper and write down this information. This is before we go into compound inequalities. So compound and, if you have a word problem that indicates that it's a compound and inequality, it's going to be written in the following formats. Number one, you'll see your variable or variable expression in between two numbers and two inequality symbols. Or you can actually separate the two inequalities and just use the word and. Sometimes it's best to use this format. So I'm going to talk to you when it's best to use format number one right here, which I'm underlining. I'm going to do it in green. Sometimes it's best to use this format. If you see words like in between, or you see a range of numbers, like it may have from 10 to 27. That's a range of numbers. Use this format. But if you just see the word and, then use this format, format number two. It's format number two. Let me put that in purple so it's not all scribbling. I'm just trying to color code it. All right, so but that's if you see the word and, then use that format, okay? But if you see again words like in between or a range of numbers, use format number one, this format. Now, when it comes to compound or, they're very simple. Compound or will just be written in this format right here. And you'll usually just see the word or as an indicator that it's going to be a split inequality or inequality, okay? But pause the video, make sure you get all this written down for me. All right, let's look at the first one. Number 21 says write an inequality for each situation. Solve the inequality, then graph. If you look at number 21, it's very wordy. All right, so I'm going to go ahead and take a look. It says 9 less than a number is no more than 8 and no less than 3. So I see the word and I see before and it says it's no more than 8. No more than 8. Well, more than, usually you think about greater than, but if it has no in front of it, it's less than or equal to. Less than or equal to 8. I'm going to use the word and. And then it says no less than 3. Less than, we usually think about less than, but it has the word no in front of it. So I want to go with greater than or equal to 3. So I can see that I'm going to have two inequalities. The thing is, I only have the right side of my inequality. Here I have the right side. Here I have the right side. I'm missing the left side on both. So it's really easy to find the left. All you do is go back and look at this part. 9 less than a number. Well, that number you don't know, so that's going to be your variable. So that's my variable x. 9 less than x. So we're going to write that as x minus 9. So x minus 9 is no more than 8. So I wrote that. Let me write it a little closer. X minus 9 is less than or equal to 8. And x minus 9, there's your and, is no less than 3. So you go over here and put x minus 9 is no less than 3, which means it's greater than or equal to 3. So you solve both ands, okay? So you're just going to add 9 to both sides. So we get x less than or equal to 17. Add 9 to both sides here. So we end up with x greater than or equal to 12. And when you get ready to graph these, here's your 12. Over here is your 17. I need numbers that are greater than or equal to 12 and less than or equal to 13 and to 17. So they're going to be these numbers here. That's your solution. Those are your solutions. Let's look at 22. It says the sum of 4 times a number and 8 is between 0 and 12. So it has is between. Let me take some of this off. It has is between. So now for is between or in between, I'm going to use format number 1. I'm going to put it in between two numbers. So it says the sum of 4 times a number and 8. There's your expression. That's going to go in between 0 and 12. So I don't know the number. I'll let that be x. So the sum of 4 times x and 8. So I'm going to put 4 times x and 8, sum it, which means add them. I'm going to put them in between 0 and 12. Don't put equal, because if you're in between, you're not equal. You're just in between 0 and 12. And please put it in order. Like on a number line, 0 comes before 12. So 0 will be on the left and 12 will be on the right. Okay? And then you can solve from there. You can split it into 2 now, since you set it up like that. Or you can just solve it as is. I'm going to solve it as is. So I'm going to subtract 8 from the 12 and from the 0. So I end with negative 8 less than 4x less than 4. And then I'm going to divide each of these by 4. So I end up with negative 2 less than x less than 1. And when I graph, here's my negative 2, here's 1. No closed circles and just shade in between. And that's all you do. So that situation has answers that will fit it that are in between negative 1, negative 2, and 1. So I just want to be clear. We should understand why we didn't use the equal signs. If you don't, I'm going to need you to pause the video and call me over. Even if I'm teaching, just stop me and say, Miss Blue, I don't understand why you didn't use the equal. But if you're in between, you can't be equal to. You can just fall in between numbers. You can't be equal to the outside numbers. And let's take a look at 3. 1/2 a number increased by 3 is greater than 0 or less than or equal to negative 3. So I already see that this is an or. Okay. Is greater than 0. Not going to have an equal sign on it. Greater than 0, it looks like that. Okay. Then I have or. It says less than or equal to negative 3. That's going to have the equal sign. And I just need to set up the left side. So the left side comes from 1/2 a number increased by 3. And I'm going to let x equal to a number. Okay, so you have 1/2 a number increased by 3 is greater than 0, or 1/2 a number increased by 3 is less than or equal to negative 3. So what I'm going to do now is just solve both of these. Subtract 3 from both sides. So you have 1/2 x is greater than negative 3. And you all know to get rid of a fraction that's attached to a variable, you got to multiply by the reciprocal. The reciprocal of 1/2 is 2 or 2 over 1. I'm just going to use 2. These are going to cancel. So x is greater than -6. All right. Or if you work on this one, subtract 3 from both sides. You end up with 1/2 x is less than or equal to -6. Multiply by the reciprocal of 1/2, which again is 2. So we end with x less than or equal to -12. And then you just graph your solution. -12, -6. It's got to be greater than -6. It's got to be less than or equal to -12. Excuse me. All right, let's take a look at 24. 24 says about 20% of the time you sleep is spent in rapid eye movement sleep, which we call REM. It just means you're dreaming. Okay. So you're dreaming for about 20% of the time that you sleep. If an adult sleeps 7 to 8 hours, how much time is spent in rapid eye movement or sleep? So basically, how much time, if you sleep 7 to 8 hours, how much time of that are you dreaming? Because you're not dreaming the whole 7 or 8 hours. You're dreaming just a certain part of it, and that certain part is 20%. So you're dreaming about 20% of those 7 hours you sleep, or you're dreaming 20% of the 8 hours you sleep. That's what you're dreaming. You whatever this equals, that's what you're gonna be dreaming. Or if you're sleeping 8 hours, you're gonna dream for 20% of that. Remember, percent, you cannot work with a percent. You have to change it to a decimal. Basically, this is 0.2 or 0.20. All right, I'm gonna let x, because it says how much time is spent in rapid eye movement sleep. So I'm gonna let x equal to the time spent in REM sleep. And this one is very simple. I'm going to say that if I can find 20% of 7, or I can find 20% of 8, which means you're multiplying. And I did that because it says 7 to 8. And that's a range. 7 to 8 is a range. So I put one on the left and one on the right side. But in the middle, I'm going to put just x. And when you set it up like this, guys, if you're putting it in between, if you're putting your expression in between, and my expression is just x, because x, I don't have to really do any work besides find 20% of 7 or 20% of 8. So x will be equal to 20% of 7. X will be equal to 20% of 8. But if I set it up as a compound inequality, then once I find 20%, it's going to tell me between what hours, or from how much of the 7 to 8 hours I'm dreaming. And I'm going to use equal to on these, guys, because you can sleep exactly 7 hours. Okay? So I can figure out if I sleep exactly 7 hours, what's 20% of that 7? Or if I'm sleeping exactly 8 hours, what's 20% of that 8? So I'm going to use equal signs because 7 and 8 can be inclusive. But again, x is just equal to 20% of that, or 20% of this. So I don't have to do anything to x. I don't have to add anything to x, subtract anything from x. I just put x in the middle. And then I'm going to find 20% of 7, which is 1.4. And find 20% of 8, which is 1.6. So keep in mind, x is the time in REM sleep. So if you're sleeping from 7 to 8 hours, you're dreaming anywhere from 1.4 hours to 1.6 hours a night. Excuse me. And you just graph it, it looks like that. All right. I hope that makes sense. If it doesn't, pause the video and call me over. Again, that was nothing really you had to do with eggs, because eggs is the time we spent in REM sleep. So to get eggs, all we had to do was just find 20% of 7, find 20% of 8. And the reason why you just wouldn't go with 1.4 and 1.6 is because it says you're sleeping 7 to 8 hours. So I could have slept anywhere in between 7 and 8. I could have slept 7.5 hours, 7.2 hours, 7.9 hours, 7.7 hours. So I got to do an in between statement or an and statement, okay? A compound statement. I got the answer up here. All right. I meant for these to be erased. All right, let's take a look at 25. It says a store is offering a $30 mail-in rebate on all color printers. So they'll give you $30 back after you mail it in. You know, originally you'll spend the money and then you mail that rebate in and they'll send you $30 back. It says Louise is looking at different color printers that range in price from $175 to $260. I already know it has from and to. From 175 to 260. And you're going to set up an in-between statement. And you set up an in-between statement like this, when you use in-between with these price ranges, I know it's going to be equal to here. And please use less than, because whenever that, don't ever use greater than in these. Thank you. Don't ever use greater than in these in-between statements. I probably should have gone over that, but up here when it has format number 1, notice I use less than statements. Or it could have been less than or equal to, but never put greater than in that format, okay? Excuse me. All right, so from 175, no, the 175 is going to go here, and 260 is going to go there. I need to write this smaller so I can work it. I'm writing too big. I don't even have any room to work. And my expression is going to go in the middle, in between, okay? So it says, how much can he expect to spend after the rebate? So I need X to be the amount he spends after he mails in the rebate, okay? Okay. Keep in mind, X is not the amount that he paid originally. It's the amount he pays after the mail-in rebate. So if you have, this is what he pays after the mail-in rebate, do not subtract 30 from that, guys, because X already represents the amount he spends after the rebate. So why would you subtract 30 if this is what he spends after the rebate? So you're going to do the opposite of taking away 30. If this were the original amount, I could take away 30, okay? Because that would tell you the amount he's spending. But if X represents the amount after the rebate, let's add that 30 back to see what the original price was. So, and keep in mind, these numbers represent the original. So the original expression, the price that represents the original, the expression that represents the original price is what he spent after the rebate plus the 30. This represents the original price, guys. So the original price is represented by X plus 30. So your original price could have been anywhere from $175 to $260. All right, so to calculate what the rebate, what the price was after the mail-in, I just need to solve for X. So I'm going to subtract 30 from both sides. So that's 145 and 230. So after the rebate, the printers were anywhere from $145 to $230. And I know you can do that in your head because you can do 175 minus 30 is 145. 260 minus 30 is 230. So he could spend anywhere from 145 to 230. But if you want to use an inequality, this is the way you would set it up. And just shade in between. So after the mail-in rebate, those are my X's. He could have spent anywhere from 145 to 230 bucks. All right, let's look at 26. It says Cindy has scores of 72, 82, 83, and 89 on her math test. Use a compound inequality to find the range of scores she can make on her final exam to receive a grade of 77 through 84. So 77, 78, 79, 80, 81, 82, 83, 84. Anywhere from there, she wants to receive like a high C or maybe a 84. That's what she thinks she can achieve. It says the final exam counts as two tests, okay? So remember to find average. We add all the scores and divide by the number of scores. And it gives us our average. So we're going to make use of that. So the scores so far, 72, 82, 83, and 89. I'm going to need more room. Yeah, it's not going to work. 72, 82, 83, 89. And she has two more tests, okay? But she has actually one more test, but it counts as two. So we'll let X be the final exam score. But it counts as two, so you can do X plus X. Or you could just put 2X if you wanted to. And divide it all by 6. 1, 2, 3, 4, 5, 6 tests divided by 6. But she needs her grade to be anywhere from 77 through 84. So you're going to write it like this. So let's take all these numbers. Let's take 72. I'll pull the calculator up, guys. Oh my goodness, it's 6 o'clock. It's really late. 72, 82, 83, and 89. All right, so we got 72. I can get this to come back up, right? 72. Just what I need. It's messing up. $72 plus 82 plus 83 plus 89 is 326. Okay, so I got 326 plus 2 of those X's. divided by 6 is less than or equal to 84. And then all you have to do is multiply each one of those by 6. Okay, so let's multiply each side by 6. We're going to multiply um, this by 6. Let me do it in a different color. This by 6, this by 6, and this by 6. So I have 77 times 6. That's 42. 42 plus 4 is 46. That's 462. Less than or equal to, these are going to cancel. 326 plus 2x. Less than or equal to 84 times 6. 24. 48 plus 2 is 50. Now I'm going to subtract 326. All right, so this is 5, 12, that's 6, 3, 136. Less than or equal to 2x. Less than or equal to, I'm going to have to regroup here. It's 4, 10 becomes a 9. That becomes a 14. That's 8, 7, and 178. And then I'm going to divide by 2. That's 68. And here, that's going to be 8. Let's see. 89. Let me double check myself over here. So she'll need a score, or whoever this is, we need to score anywhere between a 68 and an 89. And that's it, guys. Let me go ahead and graph that, okay? 68 and 89, and anywhere in between. All right, so I'm just going to let you work on already. I don't have any homework for you tonight. So just work on already, any already that you have. All right, thanks, guys.